All right, we're on page 30. Is this a function with a side of domain and range? So let's start off with this idea. When I have a coordinate pair and I plot that point or I write that point, a group of coordinate pairs is called a relation. So a set of points is called a relation. Now, that relation can be a function when certain things are true. So if each x has exactly one y, then the relation is a function. And we're going to show you a couple different ways of looking at that. I like to think of a function as a machine. So, for example, if my machine is add 3 and I put a 2 in there, well, my output better be a 5. If every once in a while the machine spits out something like a 6, that means my thing here is no longer a function. So each input has only one output. Now, sometimes we'll see that in different ways depending on how the function or the relation is displayed. All right, so we have the words relation, which is a set of points. We have functions, which are special sets of points. And then for both of those, we have something called a domain, which essentially is the x values. And then we have the range, which is the y values. Now, how can we use Desmos to help us look at these things? So a lot of these questions, especially ones involving domain and range, might actually give you a function to graph, like f of x equals x squared. And so you're going to go to Desmos and plug that in, and then you'll get to see your parabola or whatever other function that gives you. And basically, then you're looking at the fact that there's this minimum or lowest value for the y values, which means there's a lowest value for the range. And so our range is from here on up on that y-axis. So if I'm actually doing this exact function, my axis goes through 0, 0 right here. And so my range is all y values greater than or equal to 0. Now I can do any x values from negative infinity to positive infinity. And so my domain is all real numbers. The other thing that you can do in Desmos at any point in time is you can also plot points. And the reason why I bring that up is because if you have a graph of a relation, whether it be points, like coordinate pairs, or it is, some sort of physical graph that looks like that, if that relation fails the vertical line test, it touches in 2 or more values, and here, of course, this vertical line would also fail, then so if it fails the vertical line test, VLT, then it's not a function. And so that can be helpful if it's a multiple choice question where you just have to literally test out and use vertical lines, and the graph that only touches at one spot at a time, that's going to be a function. All right, let's look at a couple questions and put them to the test. Okay, here we go. Question number 24. Which function has a domain of all real numbers and a range greater than or equal to 3? So a couple things we're going to do first. Domain is X and range is Y. Look at our four choices, and it's f of x equals, g of x equals, h of x equals, m of x equals. These letters that are in the front, the f, the g, the h, the m, they are arbitrary. They usually do start with the letter f and just go forward. Why they skipped, we usually would skip I, but j could be used, jkl, they went to m. All right, now each of these functions is from a different family. All right, so let's start making graphs and we can talk about what we see. And all of these R functions are all going to pass the vertical line test. All right, so let's start looking at our functions. The first function is f of x equals negative x plus 3. I know it said for a second there, add a slider. Ignore that temporarily. And I'm just going to move this out of the way. And you can see that we have a straight line with a y-intercept of 3. And it's going down 1 over 1, down 1 over 1, down 1 over 1, which goes with this slope of negative 1. So our first function is linear. And it would pass the vertical line test. I could draw a vertical line anywhere on there. It would only hit the graph once. The next thing to say is there are values that are below negative 3. So this horizontal line right here is negative 3, and there are values below that. So this is not the correct answer. All right, let's go back and put in a different function. So I don't need this function anymore. I'm just going to edit it. So g of x equals x squared plus 3. Ooh. All right, so let's go back here. All right, so and actually let's see, we're looking for a range where, I'm going to make it into symbolic, a range that is greater than or equal to 3, and I want positive 3. All right, so if I look at this parabola, which this is a quadratic, so x squared, the degree is 2. So this is a quadratic. The name of the graph is a parabola. It has a minimum at 0, 3, right? I can click on that point. The axis of symmetry, the vertical line that I can look, so an axis of symmetry looks like this. Let me just go ahead and draw a little picture right here. Our axis of, whoa, our axis of symmetry cuts it in half. That's not a very good line there. Let me try again. There we go. Cuts it in half. Is the line x equals 0. It also is the y-axis. But at any rate, this one looks good. I think this is the correct answer. Let's look at the other two for the sake of seeing two additional types of functions. All right. The next one is h of x. And we have 3 to the power of x. So I'm going to need to go to my keyboard down here and not a squared. I want this one right here. I'm going to put an x up here. And this graph starts off real slow and then explodes up. And this is what's called exponential growth. This is what we want our money to do when we invest it in stocks and bonds and things. We want it to grow exponentially. All right, so that does have a minimum. But it's minimum. Do you see how it's riding the x-axis? Its y values are greater than 0. It actually can't be equal to 0 ever. So that's kind of an interesting thing for that one. All right, and then our last one, and I'm not sure if you guys remember what this is called, but we go down to here where above the ABC we have this symbol. This symbol is absolute value. So we want the absolute value of x plus 3. And I'm going to hit enter just so it's really there. So do you see how the x plus 3 is inside the absolute value? So that means it moves the graph to the left. If I go back to this and put a plus 3 on the outside, that's when it's going to move the graph up. So if we go back and look at our question more closely, do you see how it says x squared and then take that x squared and move it up 3? That's how we get that range greater than or equal to 3. This one, which is called absolute value, and our graph looks like a V, like the value, because the plus 3 is on the inside, that means it shifts left 3. And its domain or range was then y is greater than or equal to 0. All right, so a little bit of analysis there, but which one of these is up 3? The only one is choice 2. Okay, now we move on to question number 27, which is an open-ended question. And it says, given the relation -1, 1, 0, 3, -2, 4, and blank, 5, state a value for x that will make this relation a function. All right, so when we have a function, each x has only one y output. Okay, so these are my inputs. -1, and it maps out, it pushes out a 1. Cool. 0 pushes out a 3. And -2 pushes out a -4. So this last one pushes out a 5. Basically, we can pick any other number for x except for -1, 0, or -2. So let's just say x is equal to 53. Well, that's a great number, okay? If I accidentally choose something like -2, say I say x is -2, well, now that means -2 pushes out a -4, and -2 pushes out a 5. And then the last thing to say before we even go past that is if I plot these points, go back 2, don't go down 4, and go back 2 and go up 5, do you see how they are both on the same vertical line? That fails the vertical line test, which means it's not a function. All right, so it says explain why your answer makes this a function. An easy way to explain that is when x is 53, it has only one output, which is 5. You could say that. You could say no x values are repeated. That's another way to explain that. All right, turning the page. Another question that's very similar to the previous one that tends to go like this. It says, explain why the relation shown in the table below is a function. All right. So if we look at this, you could make a graph of it. So at -1, we go up 2. At 0, we go up 4. So actually, I want more of this part of the graph, less of that. There we go. At 1, we're up at 4. And at 2, we're up at 5. So you could say my graph passes the vertical line test. Each X input has no more than one output. All right, so either of those explanations should work on why the table is a function. So then how can I complete the table below for values of both X and Y so that the new relation is not a function? Well, that means I want to repeat an X and then the output is a new Y value. So for example, if I repeat the 2, well, 2 has gone into the function, whatever this function is, it doesn't have a pattern, and the function has put out a 5 for it. So I don't want it to do that again, but if I put in a 2 and it spits out a 6, that is a problem. So I can just put a 6 there or any other number that suits my fancy. Also, instead of using the 2 for X, I could have used the -1, the 0, or the +1. So any of these X values could have gone in this box, and then basically you just needed to choose a pair that was not the original pair. All right, so pretty easy relation function question. All right, let's move on to another topic about functions, and this one's pretty easy. So evaluating functions. Basically, evaluating is using the function machine. So we have a machine, and like for example, if it says f of x equals 2x plus 5. Well, this is the machine that I've been putting that bubble in. And so I can take and say I'm going to do f of 4, and that means x is equal to 4, and I'm going to put that 4 into this machine. And so when we talk about evaluating, it's the answer that it pushes out. And of course, the reason why it's going to push out as an answer is because I'm going to input it into the machine. So this is kind of, here's the machine with the 4 in it. And 2 times 4 is 8 plus 5 is 13. So into the machine goes a 4, out comes a 13. That's evaluating a function. Now you can do the plug in and evaluate version, or you can put the function in Desmos and then show the table and evaluate that way. So you might have to type the X value into the table and then look at the output, which is the Y value. Okay, so let's show both methods. They're pretty easy. Multiple choice or open-ended, just depends. These are 2 open-ended ones. So to get the full credit, you need more than just the answer. So let's look at this first question and kind of see what the work has to be to get full credit. It says if f of x is equal to 30x squared divided by x plus 2, determine the value of, and then don't lose that f of 1/2. Now, if you're not happy with a fraction, half is equal to 0.5, and you can choose to plug that number in also. So your work literally needs to be this. 30 parentheses squared over x plus 2. And then you're plugging in the thing that's inside the parentheses, whether you use the 1/2 or the 0.5. So I'm going to put 0.5 here, and then x plus 2, 0.5 there. I don't need the parentheses around it in the denominator, but I certainly could if I wanted to be consistent. Parentheses are super important when we're up here using exponents, because if the x value is negative, we need to make sure the negative is in the parentheses and the exponent or power is outside the parentheses. So now I'm just going to put an equal sign, and I'm going to go to Desmos and type in what I have on my screen. Now, this also is true for the quadratic formula. Make sure you are putting in your division symbol, and that way you can have a complex numerator, complex denominator. So 30 parentheses 0.5 squared, and I'm double checking, yep, looks good. Go to the denominator, 0.5 plus 2, and my answer is 3. And that question is done. Now, if you wanted to check your work or evaluate a different way, this is the second way to evaluate. You plug in the function f of x, so type in the equation just as you see it, equals, divide 30x squared over x plus 2. Okay, and when you get to this, you do get this crazy graph over here. Who cares about the crazy graph, though? I'm just going to blow this up and get this out of here. This graph, yuck. I mean, like, yes, this is great, but really, this is super, super narrow, not going to be helpful to me. So I'm going to go to the cog, and this is a thing I need to remember. Under the cog is where I get a table that belongs to a function that's already typed in. So I'm going to hit table, and it creates a table that has certain inputs already presented. It always chooses -2 to +2, going up by 1. Well, our x value is not an integer, it is 0.5, and I type that in, and there it is. There's my output. It shows me this right here. So that's how you're going to get your answer instead of doing it up here, plugging in. And the reason why this sometimes is easier for students is then you don't have to worry about the whole parenthesis jazz. Nice. All right, so I'm going to clear this, and let's go do our second question. All right, so it says given g of x equals x cubed plus 2x minus x, evaluate g of -3. All right, so just as a reminder about polynomials, let me give you a quick reminder on this vocabulary. X cubed plus 2x squared minus x. First of all, since it's going from highest power to lowest power, this is in standard form. It's organized. When we're in standard form, we can look at this power of 3, and that means the degree of the polynomial is 3. And since there's no number in front of this x squared, I'm just going to grab a different color pen. There's no number here. The leading coefficient is 1, but it's technically not there visibly. The other thing to say is the constant, which is a number without the x, is 0. It's not there. So we are in standard form. The degree is 3, leading coefficient is 1, and our constant is 0, in case they ask about that in a different question. So here we go, though, doing this. This is a cubic. I have g of -3. So everywhere I see an x, I'm going to put a -3. So I have x cubed plus 2x squared minus x. This is the perfect example of why I need parentheses, because now I'm going to input a -3, a -3, and a negative 3. And if I don't type in every single parentheses matter, I need to use the parentheses or I'm not going to get the correct answer because of order of operations. So this might be an easier situation to put that down because that's going to get you the full credit. Then we go here to our calculator and we're just going to type in the expression. Let's pull this up. There we go. So we're going to type in the original function, g of x equals x cubed plus 2x. It's a small error right there. Squared. There we go. I was looking for this beautiful graph, and I'll talk about that in a second. But anyways, we're plugging in negative 3. Negative 3 is not there. I can go down here and just type in that negative 3, and it tells me the answer is negative 6. Easy peasy. Got my answer. The reason why I'm pausing here is because when we have polynomials, they might ask you about the zeros, and the zeros are the values where you hit the x-axis. So these are really crazy zeros. So just be aware of that. Like we have negative 2 point. These are irrational. So we have 1 here, 1 at the origin. That one's easy, and 1 right there. So those are called the zeros of the polynomial. There often is a multiple choice question about that. But back to this, Houston, our answer is negative 6. So make sure you get that right. And that's how you evaluate functions. Let me fix that though, because I really don't like that. Ding. So we're going to get our pen and we're going to do some erasing. Make sure your answers are legible, friends. It makes your graders so much happier. So you can just go like that. Or you can write g of negative 3 is negative 6, like that. That is another way to do it. All right. And that's that.